Imagine sitting inside 60 tons of American steel, the engine rumbling like an angry animal, and the air thick with the smell of diesel, oil, and cordite. Out front, an M60 Patton, the pride of Cold War armor, waits for its gunner to breathe on the trigger. The main gun points towards some unlucky target, but the coaxial machine gun is supposed to handle everything else. Infantry, soft targets, and the random truck that doesn't deserve a 105mm souvenir. The gunner squeezes the trigger, the solenoid clicks, and nothing. The M73 is jammed again. He swears, slams the charging handle, and mutters the prayer every tanker knows. Please cycle this time. The coax is a small part of the tank that does a huge job. It's the fast, flexible voice of the turret. What keeps the big gun from wasting shells on things that ought to be scared away by let alone. But when that little gun fails, the whole crew feels it. The commander loses his eyes, the gunner loses his rhythm, and the tank suddenly feels less like a fortress and more like a claustrophobic coffin with bad plumbing. The M73 was supposed to be the fix. A brand new 7.62mm coax built for the space age. Compact, electrically fired, easier to feed. It looked perfect in the schematics. On paper, nothing jams. Out here, everything does. The M73 turned out to be a disaster in slow motion, brilliant in design meetings, cursed in every motor pool. It spat when it should have roared, seized when it should have cycled, and turned tank crews into amateur machinists armed with screwdrivers in despair. Soldiers called it the world's most complicated single-shot rifle, a weapon that fired mostly in theory. It wasn't born evil. Like most bad ideas, it started with good intentions. Engineers chasing efficiency, commanders demanding modernization, and bureaucrats trusting blueprints more than the men who had to pull the trigger. The story of the M73 begins there, in the fluorescent glow of post-war ordnance offices, where optimism met physics, and the Army convinced itself that a smaller, smarter gun could never go wrong. After World War II, America had tanks everywhere and a problem inside every one of them. The machine guns were getting old. The dependable Browning M1919 had done its duty from Normandy to Okinawa, but it was built for an earlier world. Belt-fed 30-06 rounds, big mounting brackets, and a size that didn't play nicely with the new compact turrets of the Cold War generation. By the mid-1950s, the Army wanted something modern. NATO had standardized on the 7.62 by 51mm cartridge, and everyone wanted a slick, electric-fired, under-armor weapon that could feed from either side and fit in the cramped mantlet of a new main gun. Enter the ordnance engineers, men who could draw faster than they could field strip. They were told to design a coaxial gun that was lighter, more compact, and more precise than anything before it. It had to feed from either direction, fire from a solenoid trigger, and operate reliably after being sealed in a metal box covered in grease, heat, and bad language. It was like asking a Swiss watch to work inside of a cement mixer. The design that emerged looked clever. Short recoil action for reduced length, belt feed using push-through system to eliminate complicated feed chutes, a tiny ejection port to save space. Every millimeter of it was optimized to fit into a narrow gap beside a tank's main gun breech. On the drafting table, it was elegant. Every curve purposeful, every spring tucked just so. Unfortunately, tanks are not drafting tables. The first prototypes, tagged under the T-Series trial names, looked promising. Test guns at Springfield and Rock Island were smooth, shiny, and hand-tuned. In early reports, phrases like acceptable stoppage rate and meets basic requirement appeared beside cautious optimism. But buried deeper in the same paperwork were sentences like sensitive to feed tray alignment and ejection performance inconsistent. Engineers saw these as minor wrinkles to be ironed out later. The Army saw a green light. The rush to standardize everything to NATO specs was on, and the M73 was swept along with it. By 1979, budget cycles and political deadlines were moving faster than machine gun bolts. Adoption meant progress, and progress meant promotions. After all, no one ever got fired for delivering something that worked on paper. Inside the Ordnance Department, there was a culture of faith and innovation. Every mechanical flaw was just one clever redesign away from perfection. The doctrine of the day said technology could overcome mud, dust, and human error. But the men designing the M73 rarely had to load belts in a cramped turret or strip a gun that was hotter than a stove burner. They trusted tolerances, not tankers. By the time the weapon was officially type classified, the M73 was already a fragile balance of over-engineering and wishful thinking. It had been built to satisfy the geometry of the turret more than the instincts of the soldier. And while the memos called it streamlined, the crews who inherited it would soon find that what was truly streamlined was the process of turning optimism into frustration. Out at the proving grounds, the first live fire trials were about to begin, and the M73 was about to discover that the battlefield is a terrible place to hide design flaws. When the first prototypes rolled out to the proving grounds, everyone expected a formality. The M73 looked the part, short, compact, painted in freshly Parkerized gray, ready to prove that American engineering could do precision in a box full of recoil. Early tests went well enough to keep spirits high. Cyclic rate was fine, accuracy acceptable, and the paperwork used all the right words: satisfactory, limited deficiency, subject to further evaluation. It's amazing how polite the language of failure can be. Then came the endurance runs. Mounted beside the 105mm main gun of an M60, the M73 was fired in bursts to simulate combat. That's when the personality appeared. Cases failed to eject, links jammed in the tray, and the feed pawls chewed belts like a nervous smoker. Crews learned that firing a coax through a sealed mantlet meant every malfunction happened inside a metal cave, barely large enough for a human forearm. Clearing one was a test of patience and anatomy. Clearing two meant you missed the fight. Field reports started stacking up. One tester wrote, "Weapon highly sensitive to feed alignment. Recommend remachining of receiver guide surfaces." Another suggested, "Greater extractor spring pressure." All fair points, but the underlying tone was the same. This thing doesn't like being a machine gun. Ordnance officers brushed the concerns into appendices. After all, no system is perfect during trials, and there was always the assumption that the later production would smooth things out. Meanwhile, the tanks kept getting heavier, the turrets tighter, and the pressure to field something, anything, grew unbearable. The M60 program needed its coax, and the M73 was the only one wearing a uniform. Engineers patched small details, swapped ejectors, tweaked spring weights, and declared victory. On paper, the new gun met the spec: 7.62 NATO, solenoid fired, reversible feed, fully automatic. No one wanted to ask why the test crews were quietly requesting extra barrels, extra extractors, and, occasionally, a priest. By the time the adoption order came down, the warnings had been buried under optimism and bureaucratic momentum. Tank commanders wanted reliability. The system delivered a checklist of features instead. The first production guns rolled off the line in 1959 and went straight into the turrets of M48s and M60s bound for Europe. The official designation read Machine Gun 7.62mm Coaxial M73. Unfortunately, soldiers called it the one that'll get you killed. In the records, the Army considered the matter closed. The coax requirement was filled, the paperwork complete, the arsenal efficient. But out in the motor pools and firing ranges, the real testing was only beginning, and no one knew yet how bad things could get once the tanks started rolling for real. When the M73 finally reached the line units, it arrived like an unwanted house guest, promising to help but breaking things as soon as it touched them. Crews pulled the crate open expecting a sleek piece of modern machinery. What they found was a finicky little lump of metal that looked like it had been designed by committee and approved by someone who'd never been inside a turret. On paper, the coaxial gun's installation was a triumph of compact design. It fit perfectly beside the main gun's breech, its solenoid wired into the gunner's controls, feeding neatly from a small guide chute from an ammo box buried behind the shield plate. In practice, that perfection was its curse. There was no room to work. Clearing a stoppage meant dislocating a shoulder, and swapping a barrel took longer than refueling the tank. If you were over 6 feet tall, you had to choose between fixing the jam or keeping your lungs inflated. Almost immediately, range officers began hearing the same 4 words after every burst: cease fire, jammed again. The feed tray's tight tolerances meant the first kinked link could throw everything out of rhythm. Ejected cases bounced off the turret wall and landed right back in the mechanism. Tankers learned to keep pliers, screwdrivers, and colorful language close at hand. Some gunners claimed they could predict stoppages by sound, the distinctive ka-thunk clack that meant another drill in futility was about to start. Maintenance crews didn't fare much better. The manuals described the M73 as self-cleaning, a bold statement for a gun that needed more daily attention than a racehorse. Armorers stripped and reassembled them until the serial numbers blurred, replacing extractors and ejector springs that seemed to wear out faster than the belts they fed. Complaints flooded up the chain: unreliable under dust conditions, fails to feed after prolonged burst fire, excessive sensitivity to lubrication type. The Sheridan-like tank crews tried to be diplomatic, calling it temperamental. The Patton crews were less polite, nicknaming it the coaxial curse. A few desperate units swapped the M73 out for infantry M60s whenever they could, jury-rigging mounts with duct tape, steel wire, and hope. Those improvised fixes worked more often than the official ones. Still, the weapon stayed. Procurement inertia is stronger than frustration, and every tank already had an M73-shaped hole in its armor. It wasn't just a bad gun, it was a bad gun standardized. The Army had committed, and the crews had to live with it. In the field, the M73 didn't just jam, it embarrassed the machines it was mounted to. Watching an M60's main gun fire smoothly while its coax coughed itself to death was like watching a jet fighter drag a wagon wheel. It undercut confidence, slowed training, and convinced a generation of tankers that somewhere, in some air-conditioned office, people were designing weapons for alternate realities. But frustration can only hide the question for so long. What exactly was going wrong inside this mechanical migraine? The answer lay deep in its guts, in the geometry, timing, and heat that made the M73 less a weapon and more a masterclass in how to design failure. The M73 didn't just jam, it did so with creativity. No 2 stoppages looked quite the same, and each had its own flavor of mechanical betrayal. What made the whole mess remarkable was that, on paper, every single part of the design was a good idea. In reality, those good ideas stacked together like a tower of matchsticks, and the first burst of fire was the spark that brought the whole thing down. The heart of the problem lay in its short recoil mechanism. To make the gun compact enough to fit beside a tank's breech, engineers cut down the receiver and trimmed the recoil stroke. In theory, it was elegant. The barrel and bolt recoiled together a short distance before unlocking and ejecting the spent case. In practice, that stroke was too short to give reliable extraction under real-world conditions. When dirt, carbon, or slightly swollen brass entered the equation, and they always did, the bolt didn't travel far enough to clear the case completely. The result? A shell wedged half extracted, the bolt slamming forward to crush it like a soda can. Then there was the feed system, a push-through design intended to be ambidextrous. The belt was shoved forward through the chamber instead of lifted out and pulled back. It sounded brilliant on a drawing board. In metal, it was a nightmare. Any twist of the belt or slight misalignment of the tray could make the round nosedive into the chamber mouth. Belts needed to be tensioned just right. Too loose and it misfired. Too tight and the feed pawls chewed the links into shrapnel. One tanker described it as feeding a cat backwards. You could do it, but you'd regret it. Ejection was even worse. The designers, desperate to save space, gave the gun a narrow ejection chute that opened into the tight turret wall. Empty casings bounce off that wall, ricocheted back into the receiver, and jammed the bolt halfway through its return stroke. Some would wedge perfectly between the bolt face and the chamber, locking the gun solid until disassembled. Early attempts to fix this involved bolting on a brass deflector plate, which worked beautifully. if your goal was to make jams louder. Heat played its own sadistic part. Inside a tank turret, temperatures regularly hit 130 degrees Fahrenheit, and the M73's close tolerances meant metal expanded faster than the designers expected. Lubricants baked into varnish, turning moving parts into stationary ones. A few gunners swore that after 10 minutes of sustained fire, the gun wasn't cycling. The parts were just vibrating from the heat and pretending. And when the heat didn't get it, dust did. Coaxial guns inhale everything a tank kicks up. Sand, grit, unburnt powder. The M73's tight tolerances, polished feed tray, and delicate extractor made it allergic to reality. The old Brownings it replaced could fire after being buried in mud. The M73 could jam if you looked at it with dusty hands. Maintenance became a ritual of desperation. Changing a barrel meant removing parts you couldn't even see from your position. Clearing a jam required a partial dismount, a mirror, and language strong enough to blister paint. The manual optimistically claimed field clearance may be achieved within 2 minutes. Crews translated that as, if you start now, maybe you'll be ready for the next war. Even when freshly cleaned, lubricated, and installed perfectly, the M73 was temperamental under recoil. The vibration from the main gun shook its mounting bracket just enough to shift alignment, so a tank that fired a single 105mm round might unknowingly throw its coax out of spec. One test crew learned this the hard way when, after a main gun engagement, their coax fired exactly one burst before jamming solid, dislodged casing and all. By contrast, the M1919 and M37 guns that preceded it were loose, forgiving, and utterly reliable. They rattled, they leaked gas, and they worked. The M73 was a perfectionist trapped in a job that rewarded grit and tolerance. It was the fine Swiss watch trying to run inside a garbage disposal. Crews adapted the only way they could. They limited bursts to 5 rounds, over-lubricated moving parts, and swapped belts the moment they felt a hitch. Some units carried spares, extractors, springs, and even a full extra gun, just to keep one working weapon between them. One exasperated gunner remarked that if you wanted to disable an M60 tank, you didn't need an RPG, just throw a handful of sand at the coax slot. The Army tried to blame user error, of course. Reports used phrases like improper lubrication and insufficient training, but the evidence was mechanical, not human. The M73 didn't fail because crews mistreated it. It failed because they dared to use it. By the late 1960s, frustration had turned to farce. Tanks rolled into gunnery exercises with brand new M73s that jammed before finishing the first belt. Officers began requesting older models from storage, preferring worn Brownings to the shiny new marvel. Even the armor schools stopped pretending the problem was temporary. Every component told the same story. A weapon built to fit a blueprint instead of a battlefield. The M73's genius was in theory, its failure in motion. And when an entire generation of tank crews began treating their state-of-the-art coax as a joke, the Army finally took notice. The fix, as always, started with a new name and a promise that this time the engineers really had it sorted. By the time the Army admitted the M73 was an unmitigated disaster, it was already bolted into hundreds of tanks across 3 continents. Pulling it out would have meant redesigning mantlets, wiring harnesses, and ammunition boxes, an expensive public confession that something had gone catastrophically wrong. So instead of starting over, the Army reached for its favorite solution, rebranding the problem as progress. Enter the M73A1, soon to be christened the M219. The upgrade program promised a mechanical salvation. Engineers thickened the receiver walls, widened the ejection port, and swapped in a new extractor with a stronger spring. The bolt was reshaped for smoother travel, the feed tray reinforced, and a supposedly improved buffer added to soften recoil impulses. Every memo called it a significant improvement in reliability. The only people not convinced were the ones who actually had to fire it. In the field, crews greeted the M73A1 like a bad ex with a new haircut. It looked different, But everyone knew how this was going to end. The gun still jammed, just in slightly more imaginative ways. Empty cases now ejected farther, sometimes straight into the feed chute. The stronger extractor solved half the failures and created a new one, broken extractor claws. The revised recoil buffer worked fine until it didn't, usually about after 1,000 rounds, when it turned into a solid lump of rubberized glue. Maintenance logs went from failure to eject to failure to extract to buffer unserviceable. Progress, in other words. The Army reclassified it as the M219, hoping a new number would erase old memories. On the range, it didn't fool anyone. The Coax still coughed, seized, and refused to cooperate when covered in the slightest layer of dust. Tankers joked that the M219 stood for Made Jam 219 times. Some crews painted the nickname right on the ammo cans. Contractors, meanwhile, assured procurement officers that the reliability rate had doubled, which was technically true. The gun now functioned for 200 rounds before failure instead of 100. Statistically, that's a miracle. Operationally, it's a punchline. Reports from Europe described units reducing coax use to conserve ammunition, which is military code for "we've given up." The logistical nightmare didn't help. Spare parts for the original M73 didn't always fit the M219, and mixing the two versions in one maintenance bay guaranteed chaos. A mechanic could install the wrong ejector and not find out until the next gunnery exercise, when the bolt jammed again and someone shouted, "Who put the old parts in the new gun?" Even when everything was done by the book, the M219 refused to behave like a modern weapon. Tank crews learned to carry wire brushes, dental picks, and replacement springs as part of their standard kit. In Germany, where cold weather and moisture made lubricants sluggish, the M219 became a seasonal hazard. Crews warmed the receiver with hand lamps or rags soaked in fuel just to make it cycle during winter qualification. If the Soviets had ever rolled west, half the tanks would have frozen their coaxes solid before the first engagement. Yet, bureaucracy moved slower than the rate of fire. For nearly a decade, the M219 limped through service. Its reputation toxic, but its paperwork pristine. Army newsletters printed cautiously optimistic blurbs about continuing improvements, while tankers wrote their own unofficial manuals full of profanity and diagrams of what not to do. Some units even had M73 drills, where soldiers practiced clearing jams blindfolded, because in combat, that's exactly what it would feel like. The final straw came when comparative trials were run against foreign systems, including a Belgian gun already famous for its reliability. When the Army finally gave up on the M219, it didn't do it with a grand announcement or a tearful farewell. It just stopped showing up in the next batch of tanks. No parades, no headlines, just quiet substitutions in maintenance logs and procurement orders. The word in the motor pools was simple: we're getting a new coax. The collective response: about damn time. The replacement process was equal parts pragmatism and desperation. The Army didn't need something experimental anymore. It needed something that worked right now. The choice came down to two proven designs already serving elsewhere. The M60E2, a modified version of the infantry M60 fitted for coaxial use, and the FN Mag, a Belgian workhorse that NATO allies had been running for years without complaint. The M60E2 went into service first because it was already American, already available, and didn't require new tooling. But even it was seen as a stopgap. The M240, the American license-built FN Mag, was the real prize. The FN design had none of the M73's cleverness. It was long, heavy, and absolutely indifferent to sand, carbon, or user error. Where the M73 relied on precision machining, the M240 relied on momentum, great unapologetic chunks of steel throwing brass like a bar fight in a foundry. It was everything the M73 wasn't: tolerant, consistent, and brutally simple to maintain. You could drop it in mud, pour in ammunition, and it would still run. Crews loved it before they even fired it. Comparative trials drove the point home. The M219 fired 100 rounds before locking up. The M240 fired thousands without a hiccup. Range officers joked that they finally had to stop testing because they were running out of belts. One armor instructor summarized the difference perfectly. The M73 was a machine gun that occasionally fired. The M240 is one that occasionally stops. The swap was gradual. Tanks still rolling with M219s had to be modified. New mounts, new wiring harnesses, and larger ejection chutes to clear spent casings properly. Maintenance crews used to babysitting the old Coax couldn't believe how forgiving the new one was. It wasn't uncommon for a tank to go through an entire training cycle without a single stoppage. For men who had spent years praying between bursts, it was almost spiritual. The shift in morale was immediate. Gunnery scores improved, downtime dropped, and confidence returned to the turrets. Tankers began trusting their Coax again, leaning on it during maneuvers instead of fearing it. One after-action report from Germany noted that crew reaction to the M240 is unanimously positive, which is Army speak for they were actually smiling. Even the maintenance shops noticed. Where the M73 required daily attention, the M240 could be stripped, cleaned, and reassembled in minutes. It didn't need delicate adjustments or prayers to the lubrication gods, just a rag, a brush, and a belt. The manuals were refreshingly short, the parts common across NATO, and the barrels interchangeable. For once, logistics wasn't a curse word. As the 1970s turned to the 1980s, the M240 became standard across U.S. armor, then across the services. It wasn't glamorous, but it worked everywhere. Tanks, helicopters, infantry tripods. The Army, after decades of chasing elegant designs, had rediscovered the beauty of a weapon that simply functioned. The final verdict on the M73 and the M219 came not from a report or a hearing, but from the field. Tankers stopped talking about them. The story ended the same way it had begun, quietly, inside a turret, with the hum of an engine and the click of a trigger. Only this time, when the gunner pressed the button, the solenoid clicked and the gun actually fired. The M73 had promised innovation and delivered frustration. The M240 promised nothing and delivered reliability. Sometimes progress doesn't mean reinventing the machine. Sometimes it just means building one that works. By the time the M240 had taken its rightful place beside the tank's main gun, the M73 and M219 were fading into the same quiet obscurity that swallows every failed invention. There was no ceremony, no decommissioning order worth framing, just a gradual disappearance from inventories and training manuals. The guns that had promised a leap forward in design were quietly written off as obsolete, a bureaucratic word for let's never speak of this again. But inside the Army's procurement offices, the embarrassment lingered. The M73 had been a product of faith, in engineers, in paperwork, and in the comforting lie that complex problems could be solved by clever design alone. Its failure left a scar that reshaped how the Army approached small arms development for decades to come. Reliability, once taken for granted, became a measurable obsession. The phrase, mean rounds between stoppage, went from a lab statistic to a battlefield gospel. Every new weapon had to prove it could fire, choke, and recover without turning its operator into a contortionist with a cleaning rod. Training doctrine shift as well. Gunnery manuals that once glossed over the coaxial gun now treated it like a system that could make or break a tank crew's rhythm. Armor schools emphasized clearing drills, mechanical empathy, and the brutal truth that maintenance was not optional. Soldiers had learned the hard way that inside a tank, a single malfunction could cascade. One jammed coax could delay a reload, block a field of fire, or expose a crew in the worst possible moment. The M73 didn't just teach mechanics, it taught humility. Industry learned the same lesson in its own way. Contractors who once promised the moon in performance figures found themselves under stricter scrutiny. Field testing became harsher, longer, and less forgiving. Designers were told to think like soldiers, not engineers. The mantra became simple. If it can't survive dust, heat, vibration, and neglect, it doesn't belong on a tank. The days of acceptable stoppage rates quietly ended. Among soldiers, the M73 earned a different kind of immortality. In motor pools and maintenance bays, it became a unit of measurement for bad ideas. A piece of kit that didn't work was as bad as an M73. The name itself became shorthand for anything overly complicated and underperforming. Bureaucratic optimism turned into folklore. Every crew had a story about one. The jam that wouldn't clear, the barrel that fused in place, the brass that ricocheted right back into the ejection port. They laughed about it because the alternative was remembering how dangerous it really was. Ironically, the M73's failure paved the way for one of the most successful machine guns ever fielded. The M240, the weapon that replaced it, set the new standard for coax reliability. Its endurance in service, decades without replacement, wasn't just a triumph of Belgian design, it was an act of institutional repentance. The Army had learned that durability beats innovation when men's lives are involved. Even today, buried deep in technical manuals and after-action reports, you can find faint echoes of the M73. References to improved feed geometry, enlarged ejection ports, or field serviceable components all trace their lineage to the lessons paid for in frustration and broken bolts. The M73 didn't survive history, but its mistakes became design requirements for every gun that came after it. In the end, the M73 was more than a bad gun. It was a reminder. It showed that reliability isn't just a feature, it's the foundation. It proved that the smallest flaw in a system can erode confidence faster than an enemy round ever could. And it left behind a quiet legacy written not in victories, but in the relief that followed its disappearance. Every tank crew that ever cleared an M73 jam by hand earned the right to appreciate the satisfying clatter of a weapon that actually worked. When the M240 barked through its first belt without a hiccup, it wasn't just firing bullets, it was firing a eulogy. The act of clever disasters was over. From then on, the Army stopped chasing the perfect gun and settled for the dependable one. Because the M73 had already proven the cost of getting that equation backwards. I'm Dave. I appreciate you watching. Please subscribe, like, comment, and share. And until next time, stand tall.